Okay, so now we're back here. Let's start. So this is chapter 2, programming with numbers and strings. Probably one of the most important things. I'm teaching an advanced Java class right now, and the student messaged me this morning. I just have no idea what I'm doing. And I looked at his work, and okay, we're in chapter 10 now. So I told the guy, I says, based on, there's certain things he's missing. So I said, you really need to go back and read chapter 3 and chapter 5 in that book because you're missing those concepts. Strings are one of the concepts. Obviously, this is in Java, but if you really understand strings really well, you can do, that's a very large part of Python. Okay, so numbers, strings, big deal. It says numbers and character strings are important. They're data types in the program. When you get input, one of you, so you back there were doing the input with a GUI, weren't you? Yeah. And whenever you get input with Python, it automatically comes in as a string. Even if you get in a number, it's still a string. So you have to realize whether you want it to be a string or not, it is. Then you're going to have to figure out ways to manipulate it and typecast the string into an integer if you want to, or into a double or whatever. And they'll tell you in this chapter that Python is kind of different. You can actually declare a variable as use a variable as an integer, then as a double, then as a string, literally, it doesn't care. It just changes on the fly. A lot of other programs don't do that. Okay, a lot of them don't. Okay, so we're going to learn how to declare variables and constants. We're going to learn how to play with strings. We're going to learn how to play with numbers. We're going to learn good coding layout. So lots of different stuff. Okay, let's talk about variables first. A variable is a name storage location in a computer program. So if we're going to store something somewhere, we're going to store it in a variable. Okay, we define it just by giving it a name. I'm going to bring up idle. And I could say, my name equals Ken. Oops. I don't know why I hit that other thing. Hold on. Where's my mouse? Okay. There you go. What that did was it created a variable called my name, and it stored the value of Ken into it. So it took a location in memory and put something in. So from now on, I can literally just type my name. I can also type print. I'm off by one key. Oh, that was almost a word, though. I can also print it. Lots of stuff. I could also do print. What do you think will happen if I do :1? Right? Seriously? Hold on. Hold on. You got the brackets in there. Square brackets. My bad. That tells us to print the first character. It's kind of handy. Now, what if I did this here? 1: What do you think?
Last character?
Yeah, last 2 characters from 1 on.
Yeah.
Okay. See, the :1 says start at the beginning, going to 1. That's not including 1. And the other one says starting at 1, go to the end.
Is it not 0 indexed?
It is. It is
Okay.
0. We'll cover that a little bit more.
Okay.
So 0, 1, but not including 1. That's why. Okay. So there's lots of stuff we can do in here. You can strip it. You can splice it. There's lots of, and you'll see how all that works. Okay. So define a variable. You can give it a name. And you can always, you can reassign it with different values. You can use variables in mathematical expressions. You can, use a plus sign. What's a plus sign? Anybody know? Got a couple different operations. One of them is plus. It can add stuff. Another one is concatenation. You can put strings together. So we're going to learn more about that. And we also have an assignment operator, which is an equal sign. Depending on the language, those change as well. Well, we'll see. Now, a lot of people think an equal sign is an equals. Does it equals? It does not. That's an assignment. You need 2 of those to handle equals. And we'll talk more about that. But beware, the equal sign is not used for comparison. It's an assignment operation. Okay? All right, the value of the right side of the sign is assigned to the left sign. So here we have total equals 0. So the 0 is put into total. The second example, bottles times bottle volume is multiplied. That is stored in total. Total plus cans, so they're all put into there as well. Okay. So soft drinks are sold in cans and bottles. Star is a 6-pack. 12-ounce cans are the same price as the 2-liter bottle. What should you buy? Well, first of all, you should drink water. So which one's better? Did they do the math for us? Okay. I don't want to walk through all these because we'll be here literally for a week. But figuring out, I mean, have you ever looked at that when you went to the store? Which is cheaper? It drives me crazy, like when you buy canned goods, you know, this one's, 12 ounces, this one's 14 ounces, and, which one's cheaper? And the thing that really gets me is soap. I'm assuming we all use soap at one time or another. I used to like dial soap. Well, dial soap all of a sudden started curving their edges. Why'd they do that?
Efficiency.
What?
Cost efficiency.
Cost efficient. It's basically by curving the edges, now they're including less soap. Then they started instead of, they had dial in, it's not embossed, but dug into the soap. So again, they less and less soap. And you look at the, how much comes with it, and you'll notice it keeps going down. It's like toilet paper, same thing. The amount you're getting keeps going down. So you can use very easily write programs to calculate different things. Okay. When working with numbers, a couple different types. We have a whole number or an integer, decimal integer. It's like a 7. It's a complete number, no decimal places whatsoever. Now we have a fractional part, like 8.88. This is known as a float or a double. Either way will work. Okay. Then we have a string, which is a sequence of characters like Bob. We are case sensitive here, so remember that. Okay. So right here we could do cans per pack equals 6, and volume is equal to 12. Now, most other languages, you have to define the data types. You have to tell it it's an integer, it's a double, it's a float, it's a string, and whatever. But here, excuse me, you don't have to. Okay. So if an existing variable is assigned a new value, the value replaces it. So an example here, cans per pack already has 6 assigned to it. We created a variable, we assigned 6 to it. Now here we really took the same variable and assigned an 8 to it, okay? Just overrode it. What happened to the 6? It's gone, okay? Totally gone. You can never get it back again. All right, cans per pack is cans per pack plus 2. We could do that as well. We could do math, and the value of whatever was in cans per pack is replaced with it plus 2. So if it was equal to 6, now it's equal to 6 plus 2. Okay, pretty easy there. In that case, it ended up being 8 to 10. Since data types associated with a variable are not the value, a variable can be assigned different values. So here it can have an integer. Then later we can make it a float. Then later we can make it a string. Very few languages allow this. Python is one of the only ones that do, and it drives me crazy. Obviously, you've programmed before, and I like to really know what the type of a variable is, and in Python, it's whatever you feel like using it as. So it's kind of.
Is it duck typing it, or is it loose typing it? I mean, is it assigning something in behind the scenes, or is it?
It is based upon what you're passing to it.
So it's a duck type.
Yeah.
Okay.
But yeah, but it's changing. So you literally can have 3 lines of code, and it literally changes its data type. I just hate that. I really do. It's kind of like in a VB script. If you did not assign a variable type, it became varchar.
JavaScript's like that.
Yeah, it's just like whatever. It assigned the largest data type possible, which is, I don't know, I'm just not a fan of that. Okay, here's a program. When someone asked me about Wing, I'm not using Wing. I like idle better. If you want to use Wing, I'm totally fine with that. If you want to use PyCharm, you're welcome to use that as well. But I just like idle. Okay, here's the example. They get a 5 printed out. They get a 5.5 printed out. I don't want to walk through all these. It'll just take too long. Okay. Now they're doing something here. Print tax rate plus question prep. Let's see what that one does. Okay. Bring up my program, and I'm going to type. See, I'm going to start a new Python program. I'm going to go File, New File, And I'm going to put in my code. I'm going to say tax rate equals, what is our tax rate now? 9 point,
Why not?
is it 9.5? 9 something. Tax rate is 9.5, okay? Now, the first time I got to run this, I say, hey, you must save it. So I'm going to save it. I'm going to put it on my desktop so I can find it. I'll put it in my Python directory, and I'm going to call it, what's the date? 27 August. 27 August. Okay. So now I'm going to, so if I had to say print and tax rate, save it again, and you'll notice I got 9.5. So what it did is my program assigned the value of 9.5, then it printed it. Now what happens if I do this? All right, let's run it. Okay, and it doesn't like it. So anyone know why it doesn't like it? Well, let me, what is this? I'm logged in from another device. Okay, handy. Must be Roy. What's happening here is tax rate we know was an integer, okay? So we try to use string concatenation and integer to a string. We
Is
get
it
it.
an integer?
What?
It's not an integer, is it? It's a float.
Well, I'm sorry, float is the point. But I'm going to change that. Now I'm going to change this from a float. Yeah, because they first assigned as an integer. Now let's run this thing. You notice now my error went away. Because what it did now is it says now it's a string. So it output the string and use the string concatenation character to concatenate it with these question marks. So that's why we got 9.5 question. But again, if I have it as a float, I get the error because it's trying to use the plus sign as string concatenation. It's like, well, you can't add, float and string together. So how can I fix that? Well, one way you can fix it is you can always convert this one to a string. You can say str. What that does is it converted it to a string. Or, there's many different ways you can do it. Or you could also do this. You could just put a comma, which I think I showed you that last time. Now what I'll put the number 9.5 and then the question. So a lot of different ways. But if you ever get that error about unsupported operand, it's basically saying you can't use the plus. You can't add a number to a string. Now in Java you can. So that's kind of weird. All right, so we will cover that more here in a little bit. Okay, so here's some stuff. 6 is an integer, okay? -6 is an integer as well. 0 is an integer, 0.5 is a float. And we got float, float, float. And don't use commas, don't use spaces, don't use anything else. So if you want 3.5, you need to put in 3.5. Okay, easy enough there. Naming variables. Variable names should describe them. So can volume is better than CV. Makes sense. Okay. I always start mine with a lowercase letter, and the second letter of each word is an uppercase. That's also called camel case. Do you have to do that? Well, let's find out. Let's go to my code over here. There's my code. So here, this is camel case. I have a lowercase t and capital R. Replace that with a lowercase r. It didn't work. Why? Anyone know?
Did you change the other one?
Exactly. I only changed it in one area. Now is it going to work? It's still going to work fine. So why does it matter?
Can you just read it better?
Yeah,
It's easier to read. Much easier to read. And it's one of those things that if you get in the habit of doing it, it's kind of like blinkers. For a while there, it wasn't a law you had to use your blinker. I guess it is now, someone told me. I don't know. But, it's just hard. Things, and if you stick with the standard, just stick with it. I had a guy submit his Java program yesterday to me, and it was so screwed up. He goes, well, I'm used to writing VB. Well, it's time to change that, because I mean, he literally had the word string with uppercase, the next time he used it, it was in lowercase, and his variable names were inconsistent. I'm like, man, if your VB code is like that, that sucks to begin with. Because even if it's not case sensitive, you should still use whatever you decide to use, it should be consistent. Okay? All right, go back. So variable names. There we go. Here's the simple rules. Variable names should start with a letter or an underscore. Continue with letters, uppercase or lowercase, digits, or the underscore, no spaces. You can use other symbols, you cannot. Cannot use question mark, percent signs, in spaces. Separate words with camel case or camel notation. Use uppercase letters to signify word boundaries. Do not use reserved words. So we know print's a reserved word. We all saw that already. Could I use print as a variable name?
Yeah.
So could I use this as my variable name? Should not be able to. If it does, I'm going to be shocked. Okay, good. You can't do that. But I could do this. I could change it to a capital P, and now it's no longer the same name. But now it doesn't meet our ruling of starting with a lowercase letter. So, if at all possible, do not use reserved words at all. But if you must, then change it somewhat. Okay. Okay. So there's can volume. X, I'm a prime candidate of one of those who use short variable names, especially in loops, especially as loop counters. But for the most part, try to use names that mean something. Okay? I use names sometimes that are excessively long. And I don't know if, does anyone know if there's a limit on Python names? I know in Java, I think it's 32. You can have names that are longer, but the first 32 characters must be different. So I'm not sure on Python. Because I've used names that are longer than 32, and then it causes issues. All right, number 6, it cannot start with numbers. Can volume has a space. Class is a reserved word. Can't use the whole slash symbol there, with a period. Okay. Just some examples of variable names. It says choose definitive names. Which variable names are more descriptive, scan or can volume or CV? Obviously can volume. If I saw CV without seeing what it was in, what do you think I would think it is?
Resume.
A resume. Curriculum vitae. Okay. So depending on, like, as a professor, I would say resume is the CV. You guys are probably like, I don't know. So it's important when programs are written by more than one person. So as a constant, a Python is a constant whose value should not be changed. I always love that. Should not be changed, okay? It's a good idea in Python and all languages to write your variable names in all caps if they're constant. So, I just love that. Should not be changed. So what does should not mean? You shouldn't change it, but can you change it?
Yes.
Yes. You should not speed. But guess what? You do. Okay. So it's good to use to start name constants to explain numerical values. So for instance, if we're using a bottle where the volume would never change, but nowadays volume changes all the time, so that probably would not be a good idea. Okay. Does Python let you change the value of a constant? Just because you can doesn't mean you should. Okay. Some languages, a constant is a constant. All right, name is it's customary to use all uppercase when using constants, just to let people know. You don't have to, but you can. Okay, comments. Use comments at the beginning of each program and to clarify details of the code. Okay, you saw in the one I showed you, I actually had comments at the very top. Back when I worked at Tinker, every file had it at the top. And anytime you changed it, you added to that. You didn't take anything off, but you added to it. This day, this person, and what we did. So the date, your name, and what we did. Every time we changed it. That way it's like a historical list of what's been done. Okay. All right. It says comments are a courtesy to others in a way of documenting your thinking. Comments to add. Actually, let's go back and look at my code for a second. I think there was a couple sections where I actually did write comments in it. Let's see. Did it open? There we go. Okay, put some at the top. But there's a couple sections. There it goes. Tuple to hold the return value. I just wanted to, I did this, I knew it was a tuple. Then what is this for? This is a variable to store the results. So I put a few of them in there, didn't put a lot. A lot of stuff I was just commenting out because it didn't work. Here's one. This does this, this does this. So I do put comments on some of it. You like that?
Yeah.
That was it's a shitload of checkboxes. I'll bring up the other program so we can see how this one actually works later. There's another one. Oh, this one's split. Okay. So split the list in two and put checkboxes on there. Because what we were trying to do is when this program runs, it makes a graphical interface of all the different John the Ripper options. And I select like which ones I want, like a shift case and substitute and this, that, and the next thing, and say go, and it does everything for me automatically. So pretty cool. So although I don't have tons of comments, we do have some. Okay. So this one's for all the substitutions. Okay. I want to know exactly what was stored in this one. What it was this. Below takes all but substitutions in MR. Let's see, I have a few comments in there. There's the multiple rules. Okay. It doesn't have tons, it just has some. Okay. So let's see when I tell you about comments. And I do not normally put in comments that are really super explanatory, but for you guys, it wouldn't hurt. A good rule of thumb is for every 10 lines of code, you should have a comment, or anytime functionality changes. So you're doing something, then you do something else, tell me what you're doing. Okay? They're courtesy of others. They add explanation for humans to read your code. They're totally ignored by the compiler. So when you compile it and run it, the computer could care less. So you literally could have a book in there. Now, I have had students who literally write multiple lines for every single line of code. I would say that's a little excessive, but it's handy later on in life. Like the first time we were working on this program a couple of years ago, we tried something that we didn't touch it for a year. We came back to it and like, I have no idea what we were doing. So I had to go in and start all over again. Okay. Here's some examples. You'll see they have multiple lines at the top. Then they have different, yeah. A lot of people will put declare variables. And it's like, duh. But, you know, I like kind of what they're doing here. They might have a little bit too much, but they have a good amount of comments. Okay. So there's style 1, there's style 2. They're pretty much the same. Here they don't have quite as much, but they put the comment, their constants together with it, put the calculations together. So it really doesn't matter the way you do it. Okay. The undefined variables says you must define a variable before you can use it. Says it must be defined before you can use it. So in my code over here, I could not say, not that, why can't I go home? There it goes. Okay, this will not work because I can't print tax rate before I define tax rate. Okay. It's saying tax rate is not defined. So you must define it beforehand. And once we start getting into functions, you see that gets even more complex because you got to define it before you can use it in a certain area. So that all matters. Okay. Now let's talk about arithmetic. We have addition, subtraction, multiplication, division. So if you want to write something like that, a plus b over 2, a plus b divided. Why do we put the parentheses around a plus b? Anybody? No?
Solve that first.
Solve that first. What would happen if we didn't do that? It would be b divided by 2, then add a to b to the results of b divided by 2.
Computers follow the order of operation.
Right, order of operations. I tell you, anyone ever written in a language called remedy? I did. And remedy, yeah, it's I'm going to show you how Remedy would write that. Okay, so we're writing that exact code right, this code right here on the right. So here's what, here's what Remedy would write. That would all be in a parenthesis.
List was like that too.
Oh, it's nuts. Then you have the divide, then 2, then you have this, and that would be that. Like, kind of looks like boobs or something. I don't know. But a lot of languages do this, and they get so excessive. It's like, I mean, if you add 4 or 5 variables, you got to like this massive collection of parentheses, and it's like, oh. And the funny thing is, when I was doing it, I'd go in there and try to make sense of it, and I'd remove a bunch of them. And the moment you hit compile, boom, they're all back. It's like, oh, it just automatically does it for you. I understand the need for them. But come on, list the same way. It gets excessive to the point you're like, why? Why do you need a parenthesis around an 8? I guess his point is maybe I wanted to put a 2A or something.
I think it has something to do with assembly. It's so written so close to assembly.
Yeah, it might be. Yeah, but it was, wow, drove me crazy. Okay. All right. Precedence matters. Parentheses, exponents, multiplication, division, add, subtract. In other words, order of operations. Okay. And, okay. I can't think of the other way to remember it. But it's always parentheses, then exponents, and multiplication, division, then addition, subtraction. What was the word you saying?
Please excuse my dear Aunt Sally. It's how I.
Oh, there you go.
That's always where I
Prince Edward made diet sensitive.
Always remember, programmers do not throw Sasha's pizza away. That's the OSI model.
Yeah.
I just heard from
All right. So, mixing numerics. So, when we add an integer to a float or a double, it goes to the larger data type. Okay? So 7 plus 4.0 gives us 11.0. Now 7 plus 7 will give us 14, or 7 plus 4 will give us 11. But since one of the data types, it automatically typecasts itself into the largest data type. Easy enough there. Okay. Double stars is exponents. Okay. So in the example on the right here, got these double stars. That means we're exponents first, so we're going to do everything inside these exponents. Inside the exponents, we're going to divide first and add 1. Then we're going to go exponents, so this value raised to n, then b times that. So how that works? So parentheses, actually, what is then? Yeah, you do everything inside the parentheses, then exponents, and then this. So, okay. And there's the way they write it. In this fashion. Okay, floor division. We have floor and we also have top. So when you divide 2 integers with the slash, which is the one to the left of the shift key, you use floating point. If you do it the other way, actually, hold on, the other way, well, we'll get there in a minute, but you can also use floor division with 2 of those, and it rounds it. This is called integer division. Also floor division, same thing, I guess. Okay. So what this does is it rounds. No, it doesn't round. It truncates, yeah. You can never remember all of them. Yeah, this one truncates. So 7 divided by 4 is 1.75. It truncates it down to 1, and the 0.75 is gone. Okay. Remainder, here's modulus. Okay. Remainder is amazing. Okay. So 7 modulus 4, what you do here is you take the 4. Okay, y'all remember, here, let me get my drawing utensils out here. So remember these days in class, we're going to do a pen. We're going to do the 7. Remember this? Mm-hmm. Remember that way from elementary school? It probably looks the same too. Mm-hmm. How many times does 4 go into 7?
1 time.
It was in 1 time. So we subtract 4. Wow. We go to 3. Then we would write R3. Y'all remember that?
Oh,
Yeah.
So modulus is remainder. That's all it is. Just a remainder. It's really handy, and you use it a whole bunch in cryptography. Most of you are probably cyber majors. You'll use in cryptography massively. It's used all over here.
How do you just know that 7% 4 means 4 in the 7?
Because the percent sign is a modulus symbol.
Okay, okay.
Yeah. Some languages like, which one do you have to write out MOD? Is job do you have to write out MOD? I can't remember. Some language, you actually have to write out MOD. I can't remember which one it is all of a sudden. Maybe it is Python. We're going to find out right now. We're going to find out right now.
Isn't it C?
It might be. So let's get rid of this. We're going to do print 7 mod 4. Let's see what we get. Nope, didn't have a clue. Wait a minute. Oh, hold on. I got to fix. Let's get rid of these other 2 lines. So it's 4. Yeah, that one works. So which one is it? Maybe it is C. No. Yeah, so it's definitely not Python. One of the languages, it could be C. I can't remember it offhand. But you actually have to write out MOD. Okay. All right, so that's modulus for calculating remainders. People always say, so why would you need that? Try to figure out the days of the week. You could actually do mod 7 and figure out the day of the week if it's on. When I wrote a program years ago that the military used, I had to determine the day of the week it was to determine when they were going to go away. You know, mod 7 if it was a 1 or 2 or 3 or 4. So there's just lots of different ways to use it, and you'll see later on. All right, here's a simple example: dollars and pennies. Modulus is great for determining how much is left over. Okay.
Oh,
That.
remainder.
Yeah, so convert pennies to dollars and cents. You have that many pennies, so the number of dollars is equal to the number of pennies, floor division, 100. They'll give us that exact number of dollars. Then the cents becomes pennies modulus 100. That'll give us the amount left over. And you can use that for cents.
I may have just completely missed it, but what's floor division? I may have just
Okay,
missed it.
let's go back to.
Sorry.
Right here, not a problem. So 7 divided by 4 gives us 1.75. 7 divided by 4 with a double thingy is integer division. It gives us the 1. It cuts off the 0.75.
Okay.
So instead of 1.75, we get just 1. So also known as integer division. No. Okay.
Thank you.
Yeah, that's a good question. Let's go into my compiler here. What is 7? So 7 like this, we should get 1.75. 7 like this, we should get 1. No, I thought we could do that though. No, okay, that's in Java. That's another way to do it. Okay. I just got too many languages going on in my brain right now. Especially when I teach all of them at the same time. Okay, because I'm actually teaching assembly, some assembly, Java and Python at the same time. So,
Sometimes.
yeah. Okay, integer division, remember examples where I talked about that. But, so n modulus 10, okay, so the 10 goes in front, but again, the value is 9 for any positive integer. So, oh, this is what ended, 1729. That's easy to see because since we know base 10, we're going to end up with a 9 every time. Okay, so there's just some different examples there. Calling functions. Recall that a function is a collection of programs instructions that carry out a particular task. Back in the program I wrote, I'm going to show you some of my functions. Okay, so I have a function called check word. Okay, this function is defined as a function, defined as check word. It receives a word and the rule. And then it does something. Okay, it just does something. Okay, here's one return word. The return word is very short. It's just this section right here. What I did with the return word is I open up a word list and I read it into lines. Then I close it. Then I randomly pick a word from there, get rid of all the blank space on either end of it, then return that word. Because when I want to create this assignment, I don't want, first of all, there's no such thing as true random. Okay. But if I was to pick a word, I would probably, navigate to a few words more than others. So by using the computer to pick it, but then the problem I had with that was sometimes it was pick words that were too short and they wouldn't work and it just calls up that. Here's why I actually did the encryption. I used MD5 crypt, and I used assault of link 4, and I stripped off the password and a bunch of other stuff. So this is a function that I defined to return a random word. So if you had a file called that, it would literally return.
Are you doing hash collisions, or are you comparing the key to the key when you're the guess to the actual?
Okay, right here what I'm doing is I'm actually, after I create them, so I'm creating it right here into the hash. Then I'm running John Checker, which is another separate file, which runs the actual, it calls a separate utility to run John the Ripper and get its results. If it broke it successfully, that would be called my result. Then I just compare them.
I mean, I guess what I'm asking is, when the program tries a value for a password, is it running the MD5 and then checking hash against hash?
Yes, it does hash against hash. Yes.
Okay.
That's exactly the way it does. Yes. Yep, exactly. Okay. Actually, I'm going to run this. We're going to see how this works. I'm going to go over here to my other program we were just working on, which you guys can follow along if you like. I'll put it up here big enough so you can see it. Okay. Now, I need to import random. Actually, I'm pretty sure I do. Let's make sure. Okay, and it should not run. Okay, good. Didn't need a word list first. I'm going to make a list. A new text file called word list complete. And say, hi there, how are you? My name is Jenny. Okay. Ken slash word list complete. Okay, still, I'm in the wrong file again. Still should not run because I'm not importing random yet, but let's make sure. Yep, random is not defined. So up here, we'll do import for random. There it comes. Okay, it did work. Now if I do print, yep, I get a U. And that is
You is you. Words of wisdom. Also.
Hush. Click the wrong. Ken.
You is you, Ken.
Okay, so we haven't covered all of this yet, but let's just talk what this one does. Okay. And this is a separate function. What I try to do is, if I need to do something over and over and over, well, I write the code multiple times. You agree? Now, obviously, if I'm creating thousands of random passwords, I need to do something. I need to get a starting word thousands of times. So this here basically is defined as a return word. I could have called whatever I want. There's parentheses here with nothing in the middle of it. That means there's no arguments. I'm just saying, give me a word. I'm not specifying anything special. One thing which I know I should fix is I need, later on in my code, which I'll show you another time, but say I'm going to, substitute something. Say I'm going to substitute an A. Wouldn't it be nice if the word had an A in it? Make sense? So what I ended up doing was pick the random word, but then randomly pick from the random word. But so I opened up a file. This basically says open word list complete as F. Okay. F is for file. Could have a better name, but it's okay. Then here I say word file, which is my new variable. I'm assigning the results of file.read lines that read the entire file in. Okay, then I close the file. So now the file's closed. So word file now contains everything. The next thing I do is ran word, another variable. I'm assigning it random. Now random, remember I ran a second, didn't have a clue what random was. I took to import random. Random is a library built into Python that handles random stuff. And there's multiple different ways to use it. So random choice. And random choice says out of here, which is the list of words, just pick something. So it picks a word, and the strip gets rid of spaces. Not in the middle, just at the ends. Because we're all guilty of sometimes you type, you might hit a space, and spaces really cause issues with my program.
Does that also get rid of the /n or
Yeah,
whatever?
the line, line feed all, yeah. It literally is now just a word. Then all I'm doing is returning this random word. That's all there is to it. Okay. Actually, let's modify this just a little. I'm going to go in here and type print word file. So you'll see it actually got all of them in. See that? So it gave it to me as an array of values. But I need strip because the /n like you're talking about. It gave it to me because when I typed in hi, I hit enter. I typed in there, I hit enter. So we had to get rid of all the /n's. Yep. Then we end up with just the word. Without the /n, trust me, cause all kinds of problems in my code. All right. Easy enough how that works?
Mm-hmm.
And now I can call this, now there's a couple ways it could be written better. Does anyone see one way right off the bat?
Are you holding all that in the keys? I mean, in the memory? I mean, is that all in the key space, or are you? Is that what the F close does? Pulls it back out of?
Right. That closes the file, but along the same lines, Word file still does contain the entire thing. And my Word file is 30,000 lines long, so we're holding a bunch in memory. But the moment we hit here, it does dump it out of memory, which is good, free up memory. But it brings up the question, I'm having to keep opening this file up and keep reading it in every time I need a word. Would it be more efficient to read it in one time, the top of my program, than anytime I need one, just call this one line? See what I'm saying? 6 1 half dozen the other. It probably would be quicker to read the, have this section done right at the very top, like maybe instead of return a word, called it read file or something. Then I just have to call this one line because, but again, there's no program that's ever perfect. And I have not done any statistical analysis to determine memory usage and whatever. But yeah, this file does get quite large. And I'm definitely not the expert Python programmer, but it works. You ever heard of something called code golf? I know you probably have. Tell them what golf is.
Yes.
So what's a better score in golf?
Lowest possible.
Lowest. So we do code golf where we take code and see who could cut a line out.
Oh, I understand.
So get it one line shorter, one line, like index sequence in cryptography. I think I got down, including using Java, including the public and the main method. I have down like 4 lines of code. So it was like so super short. That's called code golf. Yeah. How can I make it one line better and one line better? And again, calling this 2,000 times, and actually with 2,000 passwords, you would think 2,000 times, but it's probably closer to 3,000 or 4,000. Because sometimes when I read in a word, maybe I want to substitute an A, B, and a C, but the word doesn't have A, B, or C. I got to pick another word. Or sometimes I need to do something and the word's not long enough. Or it doesn't. Or sometimes it's too long. Because there's some of the rules like reflect. Reflect is taking the word random, or rand word, and flipping it over. So it becomes rand word, DROWNAR. And if it's longer than 16, it's too long for John the Ripper. So if it's too short, or if it's too long, or if it didn't contain the right stuff, I had to keep calling this method over and over. So then but it works. Okay, so let's. All right, so calling functions. A function is a group of instructions that you can call over and over. Print is a function. Because one calling function must provide the correct number of arguments. Those are the things inside the parenthesis. What happens if you call print with nothing in it? Really, just a blank line. That's all you get. Just a blank line. Because you can tell the print anything. Okay. Okay. If you don't have the correct number, it'll give you an error. All right. Functions with a return value. I just showed you mine. See, in other languages like Java, you have methods and functions. A method does something. A function does something and returns a value. In Python, they're just called functions. So it really depends on the language you're talking about. But a function that returns a value, like I showed you in my example, return word, it returns something. Okay. Absolute value is a function that will give you the absolute value of x and return it into this variable. Okay. So then you can print this because this returns a value to the print function. Easy enough there. Okay, built-in math functions, absolute value, round x, round a number, round x with an n to the number of decimal places. Very handy tool, by the way. Max will give you the largest, min will give you the smallest. You know, you look at this stuff, you know, anyone ever remember a Sylvan Learning Center? Anyone ever heard of them? I don't know if they're still here, but there was one over by Crossroads Mall at one point. My niece came to live with me from Connecticut. She was having such a hard time with math. So we put her in there. She was in there, I don't know, for a long period of time. I guess after 4 or 5 or 6 weeks, something like that, we went in for our parent-teacher conference to see how she's doing. She goes, oh, she's doing absolutely amazing. I'm like, great. What did she learn? She's mastered absolute value. Like, okay. No, she's got it down. I'm like, and? No, she's got that down. I'm like, we've been here $115 an hour, you know, once a week, and it's like, you know what absolute value is?
Yeah.
You take off the negative of the positive. That's it. So I'm like, we literally said, thank you very much. You never came back. But I mean, but you look at this, like, why do they need methods for it, or functions for it? Well, because it might be easy to us, but it's not easy to a computer. Computer is very precise. So you need to tell it exactly what you want. Okay. All right, there's libraries like the random library I just showed you. Library is a collection of code written and compiled by someone else and is ready for you to use in your program. There's tons of stuff. In that code, I also use something called passlib. It's a password library. It's got all the encryption you ever wanted to do. Why would I write MD5 encryption by myself? Why not have someone who's experienced in it, who's done it, who's tested it, and I can just use it? That's why we do these things. It's like print. When I first started teaching Java, print was not an option. Systems that out there print line? No, wasn't there. Actually, you had the input was not there. I'm sorry. The scanner class was not there. That's what was not there. Scanner class was not built into Java. You had to have an external one. And normally when you taught, the publisher or the author wrote one, then you always used the one that came with the author. I think it was Java 6, they actually came out with a built-in scanner class, which is amazing. So libraries are stuff provided to us that does a lot for us. I mean, randomness, awesome. Passlib, awesome. But random, a lot of people use, so it's built right into Java as shipped. Other ones, you just import them, okay, like that. Or you install them. We're actually going to install passlib, and we're going to install some graphics ones later on, okay? So since standard library is broken down into modules, related functions and data types are grouped into the same module, and you can figure out how to use them all. So, okay. Using functions. Here we can say from math import square root. Okay. Says square root is part of the math function. We could have just imported math as well. I think that would have, you know, let's try that. Pretty sure we could have done that. We're going to get down here, and we're going to say, what I got there, square root, SQRT, square root of 5. Okay, let's see if we get anything. We should get an error. We did. Square root's not defined. So I should be able to say import math. And that should make it work. I can't do that.
What would import? What is import math?
Does it not use dot syntax or like math dot square root?
Yeah, but I thought math. Oh, wait a minute, hold on. I don't know if I can use this. Hold on, I'm not 100% positive. No, can't do that. Darn it.
No, I mean when you call it print down there, square.
Oh,
math dot square root.
good point. Good point. Hold on, let's try that. Like that.
Yeah,
There you go. Okay. So, good point. So yeah, you can call that, or you can, like they did here, from math import square root. Okay. Just many ways you can do these things. My slides. Okay. All right, built-in functions are a set of functions that are already there. You can use them without importing anything. Like we can call print without importing anything because everybody needs that. Okay. Okay, the math module, we get square root, truncate, cosine, sine, tangent, exponents, degrees, radians, logs, so on and so forth. And there's more. Floating point to integer conversion. Okay. You can use the function int and float to convert it back and forth. So here we have a floating point. So we can use int to convert it. We could go the other way as well. We'll just truncate. Okay. No rounding occurs. Okay, here's how to use some of the different math programs. I'm not going to walk through all those. You can always find them if you need them. Floating point values are not exact. Does anyone remember, did anyone buy a Pentium 66 besides me years ago? You might be old enough. Heck, when they first came out, there was a floating point error in it. It was like at the 3,000 or 4,000th place. Intel knew about it, but didn't tell anyone and shipped them all and sold them all like right before Christmas. So everybody got them because AMD was coming out with a chip like the day after Christmas or something. So they got everybody to buy them. As soon as we all bought them with the error in them, they literally shipped us a brand new chip right after Christmas. It was kind of funny they did that, but they got a lot of sales that way. But floating point is not all exact. It's kind of like pi. How many digits are in pi? Doesn't it go on forever?
Yeah,
and it's like 10 divided by 3. 3.33333. Where does it finally end? We don't know that answer. So floating point is not always correct. See Superman 4? Anybody? Remember Richard Pryor was basically cutting off the leftovers of people's paychecks because you divide it out to the 2 decimal places, but what happens to the 3rd decimal place? Well, he was funneling all that into another account. You guys don't watch enough movies.
Office Space.
Office Space did that too?
They mentioned Superman in it.
Oh, okay, okay. See, I don't think I've ever.
Oh, you must watch it.
Is that the guy living downstairs with a stapler?
Yes.
Okay, where he got fired, but he never left. He was just down in. Okay, so I must have seen some of it. So all I know is Good Doctor's coming back out. If you haven't seen Good Doctor, it's amazing. Kind of like a new Doogie Howser. Okay, so round off errors are an issue. Unbalanced parentheses. Wow, the incorrect use of parentheses is such an issue because you're doing math wrong. Okay, I mean, look at the second one here. A plus B are in parentheses times T. Where's the other parenthesis for it? It's not there. Okay, all right, and that could cause issues. Programming tips says use spaces and expressions. You do not have to use spaces, but it's easier to read. I try to use spaces most times, but sometimes I don't. But it does make it easier to read. Okay, and here's your example here. We could have just done math.square root instead of importing the math. Okay. I thought, there it is. Import asterisk, from math import asterisk. So I think I can't do that. I gotta figure this out. Just gotta know. I can't do that. About that. No, I can't do that either. Seriously? I gotta say from math import. Well, that sucks. That's not what I want to do. That'll work. Okay. I thought I could do it another way. Oh, but so what's the difference between this and this? Anybody? So instead of square root, putting an asterisk there instead. Any difference? They both do the same exact thing. You just saw that. Well, if we say from math import square root, it's going to bring in square root only. If we do asterisks, it's bringing in square root and tangent and cosine and sine and all that other stuff in the memory. And we don't really care because we got umpteen gigabytes of memory. But what if you're writing something like the Apollo 11 lunar module that had a very limited amount of memory. Or how about maybe you're programming a ROM chip for a Raspberry Pi or something. You know, you want to make something that's so precise. You know, you don't want the wasted overhead. So
It seems like if you're cracking passwords, that would start to get important really fast.
yeah, because you run out of memory quickly.
If you're trying to
Right.
test 10,000 a second.
Right. And just by displaying results, I'll tell you, the latest version we got, I would display the results of each one as it's doing it on the screen. And I don't know, I ran it one time with all 2,500 passwords. It took about 8 to 10 hours. Then I took off the display portion of it. Instead of showing me as it was doing it, it brought it down to about 2 hours. And I thought it didn't work. I'm like, there ain't no way that thing is done. It did. It's just the fact of it displaying it slowed it down that much. So little teeny changes like that, you always want to be as precise as possible. So if you only need square root, only bring that in. Okay? Homicide time. Yeah, how about we stop here and we'll pick up on 48 next time. We'll talk about your assignment next time. Okay, we're going to pick up on 48.